At first glance, this double angle fraction looks like an absolute nightmare. But if you spot this one hidden trick, it collapses into single term. We're going to start with the left hand side. We have 1 plus sine 2x minus cos 2x. Everything over 1 plus sine 2x plus cos 2x. Now, the magic of proving this identity relies entirely the magic of proving this identity relies entirely on choosing the correct substitution for cos 2x so that the constant 1 in the numerator and the denominator will cancel out. That is extremely important. From our identity ratio, the double angle identity, we know that from the double angle identity, we know that sine 2x sine 2x is equal to 2 sine x cos x. Then cos 2x is equal to 1 minus 2 sine squared x. Cos 2x is also equal to 2 cos squared x minus 1. Now, we are going to be substituting all this into the fraction. So in our numerator, we have 1 plus sine 2x is 2 sine x cos x minus cos 2x. I'm going to be using 1 minus sine squared x. Everything over denominator, we have 1 plus sine 2x is 2 sine x cos x. Then plus cos 2x, I'm going to be using 2 cos squared x minus 1. The next thing we are going to do is to remove the bracket. So we have 1 plus 2 sine x cos x, open the bracket, minus 1, then minus and minus plus sine 2 sine, sorry, there is a 2 here, 2 sine 2 sine squared x. over 1 plus 2 sine x cos x plus 2 cos squared x minus 1. The fraction is now taking shape. It's now taking shape. This one minus this one is 0. So the one in my numerator is gone. This one minus this one is also 0. The one in the denominator is gone. So we are left with 2 sine x cos x plus 2 sine squared x. Everything over 2 sine x cos x plus 2 cos squared x. Now, look closely. In our numerator, sine x is a common factor. In the denominator, cos x is a common factor. So we are going to bring it out. In our denominator, we have sine x, open the bracket, we have 2 cos x plus 2 sine x. Everything divided by, in our denominator, cos x is a common factor. So we have 2 sine x plus 2 cos x. Note, addition is commutative. Addition is commutative. So we have sine x over cos x to be equal to, opening bracket, 2 cos x plus 2 sine x. I'm going to rearrange this. Addition is commutative. So 2 cos x plus 2 sine x. So these two terms are identical, so they cancel out. These two terms cancel out, leaving us with sine x over cos x. Note, sine x over cos x is equal to tan x. Since our left hand side is equal to the right hand side, the identity is proven. Thank you for learning with Prime Mass Hub. If this lesson helped you, please like this lesson, subscribe, and share it with your friend preparing for WAEC, NECO, JAMB, IGCSE, or SAT. Thank you.